Today we will be creating a do-it-yourself lava lamp using water, oil, and a fizzing tablet. Before getting started, let's go over some safety concerns that you should keep in mind throughout this experiment. Before starting the procedures, make sure you are aware of your surroundings and any exit points that you may need to use in case of any emergency. Be aware of any allergies you may have with any of the materials, especially the latex glove. Start off by washing your hands with soap and water and dry them off completely. Once we start this experiment, we will want to refrain from touching our eyes and face because some of the items might sting when in contact with your skin or eyes. To help keep from touching your face, use a hair tie or a headband to keep hair out of your face. Be aware that food coloring can stain skin and clothes, even though it is safe to touch. So you'll want to make sure you roll up any sleeves you have or wear something that you don't mind getting messy. Make sure you do not eat or drink during this experiment until you have properly disposed of the materials and washed your hands afterwards to avoid consumption of the materials. And finally, since oil and water can be very slippery, especially on tile and wood floors, make sure you have a firm grip and clean hands before picking up any containers to prevent spills. If a spill does occur, simply wipe it up with a disposable towel or a rag towel.
Materials needed for this experiment include a clean plastic bottle or jar, water, vegetable oil, fizzing tablets such as Alka-Seltzer, but if that can't be found, vinegar and baking soda can be substituted, a rubber glove or a small plastic bag, food coloring, rubber bands, a small funnel to make the addition of water and oil less likely to spill, a Ziploc bag or disposable container, and a towel to keep on hand in case of a spill.
Introducing the theory for this experiment, we first take a look at density. Density is how much space an object takes up in relation to the amount of matter in the object. So it's going to be the amount of mass per unit of volume. And this is seen on the image on the left of the seesaw. Two objects are shown, one with high density and one with low density. The high density object has more mass packed into it than the low density object, and since they take up the same amount of volume, the high density object weighs more and is lifting the low density object. And another way to visualize this is oil is less dense than water and will float on top of the water as shown on the image on the right.
The acid and base in the fizzy tablet will make gas that is less dense than water or oil. The gas will float above the oil, bringing bubbles of water with it and creating a lava lamp. We can trap the gas after it comes out of the oil using a rubber glove.
To make a lava lamp, take a glass or a plastic bottle, whatever you have in your household, and fill it with oil. Any kind of oil will do. Next, mix water with food coloring in a separate glass and gently pour it into the oil. Just a little bit of water will be enough. Let it settle, and then take an Alka-Seltzer pill, or you can mix baking soda with vinegar and put it inside the glass. You can see the reaction starting. To trap the gas, take a rubber glove and put it on top of your glass and wait for it to inflate. And here you go. The glove is fully inflated and says hi.
Why does the oil stay above the water? Well, water and oil are immiscible, meaning they cannot mix evenly due to having different chemical bonds. And then the oil stays above the water instead of below it due to the oil having a lighter density.
So why does the Alka-Seltzer tablet create the lava lamp effect? Well, the lava lamp effect is due to different densities in materials. So the Alka-Seltzer tablet is denser than the oil and water, so it sinks to the bottom, first of all. And the Alka-Seltzer tablet then produces carbon dioxide, which is a gas that is less dense than oil and water. The gas travels to the top of the container, disturbing the oil and water and filling the glove.
Alright, time for cleanup. First, slowly let the air out of the glove and take the glove off the top of the bottle and throw it in the trash. Now that you know why oil floats on water, let the bottle sit for 5 minutes to let the oil and water separate. Once it's fully separated, slowly tip the bottle, trying to only pour oil into a Ziploc bag. Do not pour everything down the sink. Once you can't only get oil in there, zip it up and throw away the bag. Pour the rest of the liquid down the sink and clean the bottle with soap and water so it can be reused or recycled.
In conclusion, we can see that the water and the oil don't mix, creating layers because they are indeed immiscible. And then because the liquids have different densities, the oil floats on top because it is the lighter liquid. And finally, the gas is the lightest substance, so it rises all the way to the top from the bottom, bringing water bubbles with it, creating the lava lamp effect, and the gas is then caught in the glove.